Hello everyone. In this video I would like to show you how to prepare data files that are needed for SedSat3 tool to perform sediment fingerprinting. I'm gonna basically this is gonna be a video series, so I'm gonna keep on posting videos on other features of SedSat3. In this particular video, I just want to focus on basically data preparation and then loading the data into SedSat and checking your data to make sure that it is what you want. In the video series, I'm not going to focus on the basically mathematical foundations of different tools that are available in SedSat3, but I just want to give a hands-on, essentially tutorial on how to perform different analysis, how to extract the results, and how to interpret the results, and so on. But just to give you some basics, uh, basically the foundation of sediment fingerprinting using elemental profiles is basically based on a mixing model. So essentially what we have is that we have several sources of sediments, different kind of sediments. It can be fluvial sediments or other types of sediments. But in any case, we have sources of particles mixing with each other with different ratios. Okay, here in this diagram, I've shown the ratios using the symbol x. So x sub 1, x sub 1, x sub 2, x sub 3, x sub 4. That's how much or the contribution of each of the sources into a target sample. The goal is basically what we have is that we have the elemental profiles or elemental composition of each of the sources, and then we have the elemental composition of the target sample. And what we want to do is that we want to infer these basically contributions x1, x2, x3, and x4. Essentially, mathematically speaking, now here in this equation, C is the elemental content of an element J in our target sample. So in theory, that's going to be equal to the summation of each contribution times the elemental content of this element J in our source I, which we can actually write in matrix form, as you can see here. So that's just the basics. Now, of course, there are a lot of complexities. I mean, essentially, we don't have one sample of sources. Basically, for each source, we may have multiple samples and so forth. And then there's a problem of uncertainty analysis. What elements should be included in our analysis and so forth that we're going to get to in the future videos. But anyways, let's get started. So one thing to point out, I'm actually recording this video on a Linux machine. You probably will use SedSat on a Windows machine or on a Mac computer. Everything is going to be identical. So the SedSat program is the same exact software program with same exact menu systems and so forth on any operating system. So let's get started. So basically, the data files need to be prepared in an Excel file. Okay. Now since I'm working on a Linux machine, I don't have Excel here. I use LibreOffice, but what you need to do is going to be exactly the same. It doesn't matter. So I have this basically sample data that I'm going to show you. It's called sample data.xlss, which is an Excel file. It's also available on SedSat website. So the data is already prepared. All I'm going to do is that I'm just going to open it, and I will just show you how the data should be organized. Okay, so I'm going to open this with my LibreOffice. Okay, so basically, as you can see, the first thing I want you to note is that I have 5 tabs here. I have a tab that is labeled as mixture, and then forest, crop, pasture, and bank. I want to point out that the mixture is my target sample in this case. And then I have 4 sources, including forest, crop, pasture, and bank. Now I'm going to go to all the sheets are basically formatted the same way. The first column, column A, contains the sample names. So you have one column for sample names, and then the top row of each sheet has the element names. Now, some of these things may not be elements. For example, here I have D50, which is size, total organic carbon, and then I may have some isotopes and so forth. But in any case, this now I call this constituent. So basically, the first row contains the name of the constituents that I'm going to use in my analysis one way or another. And then, of course, you know, the values that you see here are the values. So these can be the elemental contents with any units. For example, I don't know, micrograms per liter or milligrams per liter, or you know, isotope ratios, and so on. When I say isotope ratios, I mean the delta values. Now, if you look at the user's manual, this explains what they are. So this is the way we prepare the data. If you look at the other sheets, they're formatted exactly the same way. Now, one thing to point out, in order for SedSat to accept your data, the first row has to be identical between these sheets. So if I have basically one element in, for example, my one of my sheets that I don't have in another sheet, it's going to give you an error, and it will basically SedSat will refuse to import the data file. So that's the data structure. Now let's get started with SedSat, and let's try to open this. So what I'm going to do is that I'm going to go to SedSat. So this is the SedSat graphical user interface. And what I'm going to do, actually, first of all, there is a toolbar here, so you can use the toolbars. I can use this import from Excel file, or I can use the menu system, which has the same thing, import data from Excel. So that's the same thing. So what I'm going to do is that I'm going to use the toolbar bar here. So I'm going to click on the import from Excel file, and then my data is stored in this folder that I have right here. And the data that I was showing you is called sample data.xlsx. So I'm going to open that. Okay. So when I open, first this dialog box shows up. It is asking which sheets I want to include in my analysis. So basically, you may have in your Excel file that you prepare, you may have some sheets that are, I don't know, it may contain some metadata or some other information. They're not actually the raw data for the sediment fingerprinting that you want to do. So you can actually skip them. But in this case, I want to actually import all of these sheets, right? Or actually, there may be some circumstances you may have one sheet containing some data, but in your analysis you don't want to include them for some reason, right? So you have the freedom to do that. But anyways, in this case, I'm gonna check all these sheets, and then the next thing is that this dialog box comes up, and basically it's asking me which sheet contains the target samples basically. So basically in this case, the mixture sheet contains my target samples, and then the rest of them are sources. So basically, here it is. I mark the mixture as target sample, and the rest of them are source. And I'm going to just click on OK. Now I get this message box that says to not include in analysis, double click and uncheck box for the constituent. So let's just click on OK. So I get now this basically window here. Let me expand these columns so you see what they are. So basically what we have here is all the constituents that I had in my Excel file. And then I have this column that says constituent type. So basically it's asking how I'm gonna use these elements. So for example, D50 is actually particle size. So if I click here, I'm gonna see a particle size option. So I'm gonna basically change the constituent type for D50 to particle size, and then total organic carbon. This TOC is organic carbon, so I'm going to change it to organic carbon. And another thing that I can do here is that I can exclude some elements. Now we need a reason to exclude some elements, so basically we typically we can do a lot of basically some other analysis that will inform us about what elements not to include in the analysis. But at this point you can also decide not to include some of the elements. Actually, there are two ways not to include the elements. One is I can just go, let's say, iron here and say exclude, or actually here I have a column that says including analysis. I can just uncheck this one and iron is not going to be included in my analysis. Now there is another option. For example, N15 is basically N15 isotope, so it's an isotope, right? So actually I can say it's an isotope. When I select that it's an isotope, it asks me for two other pieces of information. First of all, I want to know what is N15 normalized for, because we have these delta values that are based on N15 over N, so N15 over N ratio. So the base element for N15 is nitrogen, N. And then I also have to provide this standard isotope ratio. And now what I know is if I go to Wikipedia and search for delta 15N, you can see that the standard N15 is actually this number right here. It's 0.00363. So I'm going to just grab this number and I'm going to put it here. I can do the same thing with C13, but in this data set that basically I'm using, I don't have carbon 12, so I'm going to just skip this one. So I'm going to actually not include C13 in my analysis in this case. So this is how we, and during our full analysis, we can basically we come back to this window by either clicking on this button here, constituent selection properties, or by going to settings and clicking on constituent properties, and will get us this, and we can change this. And I'm going to show you how basically one of the steps that we're going to go through is doing some basically finding out which elements are most beneficial for analysis, and basically include them in our final analysis, and basically excluding the rest of the constituents. And then we have here an option that says exclude all elements. We can exclude all the elements, and we can include the ones that we want, or vice versa, which I'm not going to do right now. So okay, the other thing you can do is that you can actually inspect your results to see it is what you want. So basically we have this three essentially data structure that we can actually look at our data. So basically if I expand samples, you can see the list of all the sources in the target, and then you can click on each of the samples, and let me expand this one, and you can see the the values, the elemental content of each of the elements in that sample, or you can do actually multiple samples and you can see them, or go to another. So let me actually check these off and then go to crop. If I click on the crop, it's going to show me all the the elemental contents for all the samples, all the crop samples actually. I can also look at the elements. So So actually here, if I can look at each of the elements, and you can see, you know, the values, elemental contents in all the samples uh, in for that particular element, um, aluminum, arsenic, and so on. And this way we can actually see that, for example, there is seem to be a significant difference between 210 lead for forest and other sources. So after importing your data from the Excel file and you know, inspecting it and you know, indicating the role of different constituents, it's a good time to save your project. So in order to save your project, you can do one of two things. You can actually go to File, Save Project As, or you can just click on this button right here. So I'm gonna do that, and then just give a name to your project. So I'm gonna call this video 1. Basically, the default extension of SedSat3 project is CMB, but I want to point out that the format is actually JSON, which is actually a text format. So you can use any text editor, including Notepad or Notepad++ or TextPad, to open the saved project and see what the content is, and the content is quite understandable when you read it. So anyways, I'm just going to call it video 1, save, and the project is now saved. Now one other thing that I want to point out is basically when you save a project, now here I didn't do any analysis, but if I do some analysis, you're going to see the analysis in this result window. And when you save the project, those analysis, the results of those analysis are also going to be saved. So the next time when you open the project, you'll have all the results of all the analysis you've done in the past. And this is all I had for this video. I will go through all different features of SedSat in my future videos. Thank you for watching.